Hello everyone, good morning to all of you. So we'll start with Comet Cloud, automatic cloud engine of unit number 6. So what is actually Comet Cloud? So automatic cloud engine. The automatic computing is a computing form of self-managing. An automatic computing scheme would command the functioning of computers, submissions, and scheme without input from the client in the identical way that the automatic tense scheme regulates poly scheme without attentive input from the individual. So here the user will not give the input to the system, it will automatically take the input. The aim to conceive scheme that run themselves, adapt of the high level functioning while holding the system complexity unseen to the user. User will not know actually how the system is working. Without the user invention or intervention, it can automatically handle. IBM, a proposal for construction of self-managing system. So introduction of automated cloud. The cloud typically have high dynamic demands for resource with highly heterogeneous and dynamic workload. The workload associated with the application can be quite dynamic in the terms of both the number of tasks processed and the computation requirement of each task. So based on that means what happens here, as the demand of cloud is increasing, the resource which are heterogeneous. So handling of this heterogeneous resource is dynamic, can be done dynamically by the cloud. So it what in the automated way. So different application may have different and dynamic quality of service requirement. So in this one application may require some another throughput should be high. In some it will depend on the budget. So one application may require high throughput, another may be constrained by the budget. So based on that, how to select the automatic cloud that should be specified. The third may have balance both throughput and budget. So these are the requirements. The performance of cloud service can also vary based on their varying load. So as well as failure, network condition, and so on, resulting in different quality of service to the application. So for that purpose, we require scale up and scale down, or scale in and scale out to support on-demand scale up and scale down and scale out and scale in, combining public cloud performance and integrating them with existing grids and data centers. User may want to use resource in their private cloud or data centers or the grid first before scaling out onto the public cloud. They may have a preference for particular cloud or may want to combine multiple clouds. Such integration and interoperability is currently non-trivial. So called as a cloud burst. It is integrating this public cloud platform with existing computational grid to provide opportunity for on-demand scale up and scale down. The Comet Cloud is an automatic cloud engine. The overarching goal is to realize a virtual computational cloud with the resizable computing capabilities. In this integrates local computational environment and public cloud service on demand. It provides the abstraction and mechanism to support a range of programming paradigms and application requirements. Comet clouds enable policy-based automatic cloud bridging and cloud bursting. So it will automatically specify what are the requirements of the customer. Based on that, it will scale in or scale out. So automatic cloud bridging enables on-the-fly integration of local computational environment like data centers and grids, and public cloud services like Amazon EC2 and you Amazon EC2 instance and EK Plus. Automatic cloud busting enables dynamic application scale out to address dynamic workload, spikes in demand, and other extreme requirements. Comet Clouds is based on the decentralized coordination substrate, supports highly heterogeneous and dynamic cloud or grid infrastructures, integrating of public private clouds and cloud burst. Also used to support a decentralized and scalable task space. Coordinates the scheduling of tasks on the set of dynamically provisional workers on available private or public cloud resource. It also submitted by the dynamic set of user. Based on the quality of service constant like cost and performance, your Comet Cloud can be changed the features. The quality of service constants are used to determine the appropriate size and mix of the public and private cloud that should be allocated to specific application request, along with the policies, performance histories, and the state of the resource. Also, demonstrate the ability of Comet Cloud to support the dynamic requirement of real application with a varied competition requirement and quality of service constant. The multiple application group feature will change of your Comet Cloud. The two application enabled by Comet Cloud. First one is a computationally intensive value of at-risk application, and second one is a high throughput medical image registration. So these two applications are using the Comet Cloud. So what happens in first one, computationally intensive value at-risk application, that is a VAR, a market standard risk measures used by senior managers and regulators to qualify the risk level of a firm holdings. The VAR calculator should be completed within the limited time. The computational requirement for calculation can change significantly. The process to determine the linear and non-linear mapping between two images of the same object or the similar objects. So in image processing or image recognition medical field, we are using this. A set of image registration methods are used by different based on your geographical distribution research groups to process their locally stored data. The set of images will be typically acquired at different times or from different perspectives, will be in different coordinate system. Critical to align those images into the same coordinate system before applying any image analysis. Policy-driven automatic cloud burst. It is an automatic cloud burst for real-world application. Automatic cloud bridging over the virtual cloud and runtime behavior of the Comet Cloud. Next point that we will go over is a Comet Cloud architecture. So Comet Cloud is an automatic computing engine for cloud and grid environment based on the Comet decentralized coordination substrate, support highly heterogeneous and dynamic cloud grid infrastructure, integration of public and private cloud based on the peer-to-peer substrate that can span enterprise data centers, grids, and cloud. Resource can be assimilated on demand or on the fly into the peer-to-peer overlays to provide the services to application. Comet is a composed of a programming layer, a service layer, and an infrastructure layer. Adapt the grid information discovery system to deterministically map the information space onto the dynamic set of pair nodes. The resulting structure is a locality reserving semantic distribution hash table, DHT table, maintains contents locally, guarantees that the content-based queries are delivered within the bound cost, using flexible content descriptors in the form of keyword, partially keywords, and wildcard. Comet builds a tuple-based coordination space abstraction using the GUID. Can be associatively accessed by all the system pairs without requiring to location information of tuples and host identifiers. Also provide transient space that enables application to explicitly exploit contents locality. Comet Cloud layer abstraction a semantic view of Comet Cloud architecture. We study that. Then the infrastructure layer uses the pod self-organizing overlays. The query information, the story and content-based routing substrate building on the top of the pod. The routing engine supports flexible content-based routing and complex querying using partial keyword and wildcard or ranges. Guarantee that all the paired nodes with data elements that match a query message will be located. Nodes provide resource in the overlays have different role. Different access privilege has been based on the credential and capabilities, provides replication and load balancing service. Then every node keeps the replica of the successor node state. If the node failed, the predecessor node merges the replicas into its state. So the replicas of new successor will be available. So this is the structure of in which we are having the programming layer, service layer, and infrastructure layer. So this is the user application. Then infrastructure layer, we are having replicas, replication, load balancing, content-based routing, content security, self-organization or organizing layer. And we're having the data center grid and cloud at the bottom. So in service layer, it is consisting of clustering and anomaly detection, then coordination, then publish or subscribe, message, event, and discovery. And in programming layer, we are having the master or worker. Then workflow is there, MapReduce Hadoop, task consistency monitoring, and here we are having the scheduling. So this is structure of your Comet Cloud.